Order of operation. Order of operation is very important. It's used in algebra, and geometry, and other mathematics. Most people know it as Pemdas. Please excuse my dear Aunt Sally. Pemdas. All it is it's an organizational tool to let you know that you would be doing parenthesis problems first, then exponents, multiplication, then division, addition, and finally subtraction. You would do these in a downward fashion, meaning anything in parentheses, then exponents, then multiplication, then. So when we look at PEMDAS, we'll see that the first thing is parentheses. These are parenthesis math problems. You'll notice that there is a math problem between two parentheses. And there's actually three math problems between parentheses over here. So what we'll do is we're going to actually do the 2 plus 2 first and give me 4. Now, that's actually pretty simple, except the next one is not as straightforward. When you're looking at this one, you'll notice that there is 3 numbers between these parentheses, and there's also 2 math problems. There is a subtraction math problem and a multiplication problem. Well, you do not just go from left to right. That is not how you will do this. What you will do is you'll need to follow the order of operation in order to complete. And if I see subtraction and I see multiplication, according to the order of operation, multiplication is actually before subtraction. You would want to do this multiplication before the subtraction. So I would want to go 2 times 4 first and get 8. Then I have 3 minus 8. 3 minus 8 is negative 5. So this is the correct way. If you would have gone left to right, you would have gotten a different number, and that number would be incorrect. If you did 3 minus 2 and got 1, and then 1 times 4 to get 4, then you would have 4 plus 4 as a math problem, which would be incorrect. This math problem is not 4 plus 4. This problem is 4 plus negative 5 to give you actually a negative 1 answer. The next, exponents. With exponents, this little number here is the actual exponent. This number you can call either a base or a root. Most people call it a root. When you see exponents, it does mean multiplication, except it does not mean 3 times 2. It doesn't mean that. You're not using this and this. What it is saying is something different. It's saying take the root 3 and multiply it times itself twice, which means take the base root 3 and multiply it times itself twice. You'll notice that there are 2 3's being multiplied, 3 by 3. That's how I get 9. Let's do this again. What if I see 2 to the power of 3? Again, it does mean multiplication, except it does not mean 2 times 3. This is not correct. What it means is to take the base, or the root, 2, and multiply it times itself 3 times. So what it means is to take 2 and multiply it times itself 3 times. Again, this is not going to be 6. Notice, it's 2 times 2, which is 4, and 4 times 2, which is 8. These are exponents. Multiplication. This is the style of doing multiplication with algebra. We need to get used to seeing it like this. More of your math is going to look like this and not like this. So with multiplication in algebra, you will have a number and then maybe slammed up against another number with parentheses. This says 3 times 2. Look at this. It looks a little bit different, except the parentheses are around the 3 now. But the 2 is still right up against the parentheses. Notice on the final one, the 3 is in parentheses, and so is the 2. But they are right next to each other. All of these are examples of showing multiplication using algebra, or showing in an algebraic way. If I want to write 4 times 2, I can write it like this, or I can write it like this, or I can write it like this. All of these are the correct way to show 4 times 2. The next one, division. Division is shown like this. Some people will call this a fraction bar. I normally don't. I just call it division. So your number 15 divided by 3 is 5. 20 divided by 2 is 10. You should get used to seeing division shown like this and not using any other symbols, because with algebra, most of the time, this is the symboling that is used for division. Addition and subtraction, they have no special symbols. They're just normal. Now, I want to point out one thing when it comes to the order of operation, and it's this piece here. Most people understand that you just go from top to bottom, parentheses, exponents, multiplication, division, addition, and then subtraction. And that's not really true. What is true is that the parentheses and exponents, they're still, you want to do them first and second. But when it comes to like either multiplication and division and addition and subtraction, there's another way to think about it. For instance, with multiplication and division, you want to go left to right. And what that means is it doesn't matter which one comes first. For instance, if I showed you this, you would say, well, Baron, doesn't multiplication come before addition? So I should multiply 4 times 2 first? And I'm going to say, no. I'm sorry, 2 times 3 first. And I would say, no. The rule is that when multiplication and division are together, for instance, in this math problem, you will go with whatever is first. When I mean left as we read a sentence. 4 divided by 2 would actually be completed first, left, and then move to the right. 4 divided by 2 is 2, and then 2 times 3 is 6. The same is true for addition and subtraction. If I show this math problem, you would say, well, very doesn't addition come before subtraction, so I should do 4 plus 2. And I would say incorrect. You would want to complete this again from left to right. And it doesn't matter which one actually is first. Okay, the subtraction's first. Here, 7 minus 4 is 3, and 3 plus 2 is 5.